Alrighty, guys, let's get started. So today we're talking about CPCTC, which is an acronym. That means corresponding parts of congruent triangles are congruent. Everybody say it with me. Corresponding parts of congruent triangles are congruent. One more time. Corresponding parts of congruent triangles are. Let's do it again. Get it right. Jen, do it this time. Here we go. Corresponding parts of congruent triangles are congruent. So if you know two figures are congruent, what can you conclude about corresponding sides and corresponding angles? So we're gonna use CPCTC to prove triangles are congruent. Let's go ahead and write this whole thing down. Okay. CPCTC is an abbreviation for the phrase corresponding parts of congruent triangles are congruent. It can be used as a justification and a proof after you have proven two triangles are congruent. Side, side equals side, angle side, and hypotenuse leg. Use corresponding parts to prove triangle congruency. CPCTC uses congruent triangles to prove corresponding parts are congruent. Now, a very important point of CPCTC. I'm gonna wait. I waited until you wrote things down before I said this. Make sure I got your undivided attention. Let's get off the phone. You only use CPCTC after you've proven that two triangles are congruent. Okay? You got me? In other words, as you write a proof, one of these 5 things has to be before CPCTC. Okay? We'll talk about that today. Kind of what we're going to go over today. So if I'm talking about triangle proofs, I'm talking about congruency. You've got to use one of these before you can use this. You got to have congruent triangles before you can use CPCTC. Think about it. How do I know that the triangles are congruent? If I'm using CPCTC. Okay. All right. I'm going to move on. I can come back if you need it. Don't worry about writing this down. Just look up here. All right. A and B are on the edges of a ravine. Whatever. What is AB? Well, check this out, y'all. A to here is 10 miles. Here to here is 10 miles. What is true about these two sides of the triangle? They are what? They're equal or congruent. Okay. Here to here is 15. That point to B is 15. What's true about these segments? These two segments are congruent. Michael just mentioned something. These two angles, what type of angles are they? They're vertical angles. Vertical angles are what? Congruent. Say it with me here. Side, angle, side. Look at it again. Side, angle, side. Over here. Side, angle, side. Do I have two congruent triangles? Yes. If I have congruent triangles, then corresponding parts of those congruent triangles are congruent. In other words, the sides and the angles that correspond are the same, are congruent. Okay? So that would mean that this angle and this angle are congruent, this angle and this angle are congruent, and lo and behold, this side and this side are congruent. So what is A to B here? 18. It corresponds with this side length. Okay? Remember, did y'all see how I had to do that? I have to prove the triangles are congruent first. Can't just sit there and say, oh yeah, CPCTC, vertical and alternate side length. Got me? Don't do that. It's a hot mess. Don't come out of that, or like looking like a hot mess. Okay? Right, next, let's do another example. All right, here we go. We got another one here. Let's see what we notice about this. What do you notice about the distance? I don't even, okay, the problem, a landscape architect sets up the triangle shown in the figure to find the distance JK across the pond when it's JK. So check it out. We had somebody asked me today, they were like, hey, how'd they do with the test? And I was like, not so great. They're like, oh, are they seeing hard problems in class? I think. So, it's hard enough for you? On its own, without the answer. Pretty difficult, what you say? It's not something you probably just sleep through, right? I don't know, but actually I do not with you. Yeah, so we do these problems, okay? I'm putting some harder problems up here. Make sure you're paying attention to how I do this, right? Before I can use CPCTC, I have to do what? Use one of my 5 theorems that prove what? Triangle congruency, okay? Got to prove that these triangles are congruent. Let's work on this. Is JL and NL, are they congruent? Yeah, sides are congruent. What do you notice about KL and ML? They're congruent as well. Hot dog, what about these 2 angles? JLK is congruent to NLM. I've got congruency there. Do I have 2 congruent triangles? Yes. Triangle JLK is congruent to triangle NLM. Through what theorem? Side angle side. Oh, he's helpful today, right? Side angle side. If that's true, are the corresponding parts of those congruent triangles congruent? Yes, because of CPCTC. So that means that MN is 41, and what's JK? Let's see how this works now. Okay? It's complicated, right? It's complicated. You got to go through all of that congruency stuff to get to this point. But, man, is it awesome. Okay? It's like, how do I explain it? It's about like, oh, I had a good analogy I used a couple weeks ago for the semester class. Kind of thing. Can't think of it right now. Okay, how about like this? No, that wouldn't work. It's just like awesome, okay? Just here. Here we go. What do I know? I know that YW bisects XZ. This is out. A bisector does what to a segment? Cuts it in half into 2 what? Equal or congruent parts. So those sides are equal. XY, segment XY is congruent to segment YZ, correct? Okay, I'm given that. All righty. What do I know? What else do I know about this triangle? Cameron Foster. Do I have any other sides that are congruent? Perfect. Through what property? Perfect answer, Cameron. YW is congruent to itself. Okay? When I say congruent to itself, here's what I mean. Let me know. I got triangle XYW. I got triangle ZYW. What did you notice the letters that were in both of those? And? Right? They're both the same, correct? Okay. So if this was a piece of pizza, and I came along, because I would do this, okay? Let's say you have this big piece of pizza here, YXZ, right? And I said, hey, cut it in half. I'm your teacher. You said, Mr. Hobbs, I don't like that. I said, cut one. Okay? So that's probably it, right? I wouldn't do it. Actually, I wouldn't. All right, so if you cut this in half, right? Think about that. You're going like this with a pizza. You're cutting it in half, correct? That side of the pizza is the same in your side as it would be in my side, right? It has to be, okay? That's the premise of the reflexive property. Do I have 2 congruent triangles here? through what theorem? Awesome, guys. Y'all see how this works? Side, side, side. So if I have two congruent triangles, what is my shortcut? What's the next logical thing I can say? The corresponding parts are congruent. CPCTC. Remember what that stands for. The corresponding parts of the congruent triangles are congruent. Okay? That means that the sides are congruent. I already have that. All of the angles are congruent. So XYW has to be congruent to ZYW through CPCTC. All right? I don't like this one so much because we haven't talked about parallelograms, but I wanted to show this to you. Mr. Bradley, I want to show this one to you. It's going to be important in your life. NO is parallel to MP. NO is parallel to MP. Let's see what that means. NO parallel to MP. That's good. I got these two parallel lines cut by transverse. What does that mean about the alternate interior angles? Here and here means that those are congruent, right? I was given this, that N is congruent to P. Okay, Cameron Foster, you're my guy here. Angle, angle, what? Angle, angle, side. Through what property? Can I use angle, angle, side to prove triangles are congruent? Yes. Okay, you got me? Absolutely, I can. Angle, angle, side proves that the triangles are congruent. I have CPCTC, and this is where it's kind of strange because it's like, how do you know that MN is parallel with OP? And that's because my converse of the alternate interior theorem is that if I have congruent alternate interior angles, then my lines are parallel. Okay? It's strange because we don't know that property yet. We can do parallelograms. Yep. Oh, parallelograms. Look at how this proof works. I started with my given information, right? Correct? I moved to what I could conclude using the given information, right? I said, hey, if these are parallel and it's cut by transversal, what does that mean about these angles? Alternate interior angles are congruent. I asked Cameron, what's true about the middle line section? He said they're congruent because of the reflexive property. I had angle, angle, side. I then said the corresponding parts are congruent. Okay, so look at how much I can use in a proof, right? I use a bunch in a proof. Okay. Holy guacamole! What if I put it in a coordinate plane? Here is the big teaching point for today, as far as coordinate planes are concerned. Have you ever noticed whenever you put something in a coordinate plane, about 95% of the time I don't tell you any angle measurements? Yeah. So which of my triangle proofs don't need an angle measurement? Side, side, side. So guess which one I'm probably going to try to use here? Side, side, side. How can I prove that the sides of these triangles are congruent? The points on the graph, and I can plug the points on the graph using what formula, Cameron, to maybe find the distance from F to D? What formula could I use to find the distance from F to D? I could use the distance formula not once, not twice, not 3 times, not 4 times, but 6 different times I can plug in my distance formula. But guess what happens, guys? Notice some patterns here. Oh, wow. Those are congruent. These These are congruent? No. These are congruent. If I had plugged these in, EF, DE, and all that good jazz. DE is congruent to HG. EF is congruent to HI. DF congruent to GI. So I have three sides that are congruent in two different triangles. Do I have congruent triangles? Now I can conclude that all the angle measurements are congruent. Not by side, side, side. By CDCTC. Remember? Okay, got me? That would be how it works. Through side, 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 I can prove that the triangles are congruent. Through CDCTC, I can say those angles would be congruent too. All right? Any questions about that type of work? If I need you to go through anything else?
They don't know.